Alright, we have a lot to review to get ready for our quiz tomorrow. First thing, we have to be able to rewrite. So we have logarithmic form. To change from log to exponential, you take your base of 3, here's your exponent, and that equals 27. And you see that that is true, that 3 cubed does equal 27. If I want to rewrite from exponential to logarithmic, this is going to be our base. Your exponent is what your number is equal to, and 16 goes there. So you have to be able to rewrite going in between both of your forms. The next thing is writing the inverse equation. Just like the inverses that we did in the previous chapter, the first step is switching your x and your y. So we've got x equals the natural log of y minus 5. And the way to switch it and get y solved for is, we know that the base here, if I rewrite this, is log base e. Or you can solve by just raising e to both sides. It doesn't matter because that cancels. E to both sides. That cancels. So you get that e to the x is equal to y minus 5. And again, there's two ways to go about doing that. Or, actually there's three ways. We could have e log e, and we rewrite it using exponential form. So, this is e raised to the x power is equal to y minus 5. What we just did, rewrite from log form to exponential form. Then to get y by itself, we add 5 to each side, and we get y is equal to e raised to the x power plus 5. Remember, logs are the inverses of exponential functions. Exponential functions are the inverses of logs. So if you're starting with logs, your inverse should be exponential. If you're starting with exponential, your inverse should be a log. Then we're still using those exponential growth and decay problems from the very beginning of the chapter. You deposit $1,000 and you get 5% interest compounded continuously. And the fact that we're compounding continuously means that we're going to use our PERT equation. So A equals your principal E raised to the rate times the time. How long does it take to have $13.50 into the account? So we are depositing $1,000. That's our P, our initial. E, our rate is 0.05. T. So we want to know when there's $1,350. That's representing our A value. And again, remember before, the only way we knew how to solve these was by graphing, but now you have to solve it algebraically. On your quiz tomorrow, you're not going to have the option of solving by graphing. So we divide both sides by 1,000, and we get 1.35 is equal to e raised to the 0.05t. Now we want to get rid of our base of e to get to that exponent. So we take the natural log of both sides, and we take the natural log because the natural log and e cancel out. So we're left with 0.05t is equal to the natural log of 1.35. So to get t by itself, we divide by 0.05 on each side. And we get t is about 6.002 years. Okay, expanding. Remember, expanding means that you're making something bigger. So you're taking the natural log and you're expanding into all of its individual pieces. So I've got 4 times x squared times y to the 5th times z. So that's natural log of 4 plus the natural log of x squared plus the natural log of y to the 5th plus the natural log of z. Remember, multiplication means you're separating your pieces by addition. Natural log of 4, well, I can rewrite 4 as 2 squared. Natural log of x squared, I can take that exponent, move it out front, move the exponent out front for the next piece as well, and natural log of z can't be rewritten. So then we just take our first piece and move that exponent out front, to get 2 natural log of 2 plus 2 natural log of x plus 5 natural log of y plus the natural log of z. With number 6, we are still expanding, so we're still going to take that and break it into multiple pieces. I look and I've got 27x squared divided by 2. So that means I've got log of 3 27x squared minus log base 3 of 2. It's this divided by 2, so it's that minus. Now when I look at the first piece, I've got 27 times x squared. Since I'm multiplying, I can break that apart again using addition. We look at our first piece, log base 3 of 27. 27 can be broken down into 3 cubed. Our second piece, we can move the exponent out front. And in our last piece, nothing can be rewritten. So we're looking at our first piece again, log base 3 of 3. That cancels out, so we've got 3 plus 2 log base 3 of x minus log base 3 of 2. Turn your sheet over. After we learned how to expand, we talked about condensing. So we just made our pieces bigger. Now we're going to take our pieces and condense them into one piece. So if I've got 2, I know that came from canceling out, just like our last problem. We got 3 from canceling out log base 3 of 3 to the third power. That number left over is the exponent. So when we look here, again I've got log base 3. So the way that works is that canceled. 2 was our exponent. Plus log base 3 of 8 minus log base 3 of 2. Since I'm adding, this means I'm multiplying. So I've got log base 3. We're only going to have that log base in our answer one time. 3 squared gives us 9. Since I'm adding 8, that means I'm multiplying by 8. Subtracting means I'm dividing by 2. 9 times 8 gives us 72 divided by 2. So we get log base 3 of 36. Number 8, we've got 3 natural log of 2 plus natural log of x minus 4 natural log of y. So we're going to condense it together. This is our exponent, so this is the natural log of 2 cubed plus the natural log of x minus, that's our exponent, natural log of y to the 4th power. So again, we're starting with adding these two pieces together. So that means I'm multiplying. 2 cubed is 8 times x, and then the subtraction means I'm dividing the whole thing by y to the 4th. After we talked about expanding and condensing, then we moved on to solving. If I am solving here, I'm solving a logarithmic equation. Since I have the same bases, I'm going to condense those like we did in the last problems. Adding means I'm multiplying, so that's 5x is equal to 4. To undo the natural log, I have to have e. So e raised to the natural log of 5x is equal to e raised to the 4th power. The e and the natural log cancel. We've got 5x is equal to e to the 4th. And if I want to get x by itself, we divide by 5. So x is equal to e to the 4th divided by 5. And when you plug that into your calculator, you get about 10.920. Then you go back and we check our solutions. So the natural log of 10.920 plus natural log of 5 is equal to 4, and when you plug that into your calculator, you see that it does work. Number 10, 2 raised to the x power plus 7 is equal to 24. We move our 7 over, and we get 2 raised to the x power is equal to 17. We want to get to our x and our exponent, so we've got to get rid of that base of 2. So I take the log base 2 of each side. Because the log base 2 of 2 cancels, and we've got x is equal to log base 2 of 17. Now remember, you can't put that into your calculator because your calculator only does common log and natural log. So we've got to use our change of base formula to enter log of 17 divided by log of 2. And you want to make sure that you're very careful with your parentheses. And you get 4.087. And check your answer and you see that it does work. Last problem for our review for our quiz. This is solving our logistic growth. And remember, we're going to cross multiply. So we've got 3 is equal to 1 times 1 plus 18 e to the negative x power. 3 times 1. Nice thing is when you're multiplying by 1, it doesn't change anything. So now we've got to kind of take apart our puzzle here to get to our exponent. We subtract 1 from each side. 2 is equal to 18e to the negative x power. Divide by 18 on each side. And when you divide by 18, you find that you get a decimal that's repeating. So we're going to use the fraction. And then we want to get rid of the e to get to the x exponent. So we take the natural log of each side. The natural log and e cancel, so we've got negative x is equal to the natural log of 1/9. Divide each side by a negative 1. X is equal to the natural log of 1/9 divided by negative 1, which is about 2.197. Make sure you look at each of these areas and you study all the different possibilities. These were only a couple examples of each of the problems. You should be able to do any variation of rewriting inverses, your exponential growth and decay problems. You should be able to solve for amounts and you should be able to solve for time. Expanding with multiplication and division, condensing with multiplication and division, and solving all log problems, solving exponential problems, and solving those logistic growth problems. Make sure you study for your quiz tomorrow.